In this video, we'll take a look at questions 15 through 20 on the end of course practice test that is related to the questions released from Ohio's 2018 geometry end of course assessment. So starting with number 15 here, we're asked, given that line M and N are parallel and transversal, and line P is a transversal, to prove that angle 5 and angle 4 are congruent. And you can see that I've already done some marking, a little bit of planning ahead here, so we see that these two angles are marked, and we know that given information says M and N are parallel. So we have different properties. Sometimes we talk about the alternate interior angle postulate, which we could just jump straight to that if it were an option. However, that is not an option in this situation, so we're just going to get to that fact that angle 5 and 4 are congruent through a series of other steps. So I started this problem by sort of looking through and seeing what's true of these possible options. We have all these options, it's nice. Angle 1 and 4 are congruent, that's true. The reflexive property doesn't really relate to the situation, so don't even need to think about that. Alternate exterior angles theorem doesn't really stand out. So when I think of angle 1 and 4, then I start to think, okay, well, if I could also connect 1 and 5, then I could get there. But there isn't anything connecting 1 and 5. So then I think about angles 4 and 8. Those are corresponding angles. Oh, and there is a statement relating angles 4 and 8. So if I can relate angles 4 and 8, and then 8 and 5, oh, I can say that, then I can tie together corresponding angles theorem, vertical angles theorem, and then that transitive property. Since 4 and 8 are congruent, 8 and 5 are congruent, then 5 and 4 are congruent. So that's the plan. So let's first state that angle 4 is congruent to angle 8. It's stated angle 8 is congruent to angle 4. And that would be, again, the corresponding angles theorem, or postulate, it's right here. Put that in. And the next, angle 5 and 8 are congruent, right here. You can see that those are vertical angles. Vertical angles theorem, check that off. And then finally, what we're trying to prove, which is 5 and 4 being congruent. And again, since 8 is congruent to 4, and 5 is congruent to 8, you can kind of cut out that middleman and say 5 is congruent to 4 by the transitive property. So that's a good review of our understanding of the relationships between parallel lines and the angles that are formed when they're cut by a transversal. Question 16 mentions that the sine of angle F, that's this angle right here, is 0.53, and then what is the cosine of angle H? So let's kind of draw this out. If this is side A and this is side B and this is side C, and we have this formula sheet that we spent some time on talking about our trig relationships. This is a trig question, not to be intimidating, just try for triangle. And then angles and sides relationships here, measures. We have sine and cosine. So sine, SOHCAHTOA, is one of the SOH is one of the acronyms people use to help remember if they don't have this right in front of them. TOA. So the sine of angle F would be opposite B over hypotenuse C. Now let's take a look at for angle H here. the cosine, see, adjacent over hypotenuse. So see how that plays out. Cosine of angle H, we switch the orientation, and now the one that's adjacent is B, and the hypotenuse is always the same. So you see here, they're the same, which makes this a super easy question, even though it seemed intimidating at first. The answer is just 0.53. And there's a trig question. Not too bad. Number 17, we'll take a look at that one. We have some triangle measures going on here with two isosceles triangles. You can tell because we have this larger triangle WYX, and then it has these sides marked, and then we have this smaller triangle ZYX, and it is also has two sides that are congruent, and you can see that the markings are actually stated in the given, and what we're trying to prove is that WZ bisects angle YWX. We want to prove that angle 1 and 2 are congruent. So we've got a lot going on down here. We see that it's just nice that we have so much information already provided for us, and we just need to fill in the blanks. So the given's already in the proof, in the two-column proof. So then next it states that angle WYX, angle WYX is congruent to angle WXY. That's this one right here, the green triangle angle here. And angle 3 and 4 are congruent. So there's angle 3 and angle 4. And how do we know that? Well, it's a property of isosceles triangles. So let's see. Base angles of isosceles triangles are congruent. So that one's going to go there. Use some abbreviations, and I'm going to cross that off. And then it tells us that it's provided for us that the measure of WYX is equal to the measure of WXY. Now that's just a clarifying piece. Measures of congruent angles are equal. So it follows directly from this statement. Since their angles are congruent, then their measures are equal. So then we have the measure of angle WYX is made up of measure of angle 6 plus the measure of angle 3. You can see that WYX is made up of the sum of those two angles. And similarly, we're going to say the sum of 4 and 5 are equal to WXY. And we can say that is based on the angle addition postulate. Next we have that the measure of angle 6 and 3 is equal to the measure of 5 and 4 by substitution. And ultimately we need to get to be able to say the measure of angle 6 is congruent to the measure, or is equal to the measure of angle 5. So what do we have by substitution as well here? We have to choose from the ones so let's see, could we just use substitution for 4 and 3? Can we do that? 4 and 3. Yes, we can, because we've already said that those two angles are congruent. So let's go ahead and put the measure of angle 6 plus the measure of angle 3 equals the measure of angle 5 plus the measure of angle 3. So we just swapped 4 and 3 out, and that's because in order to get to this next statement, we can just subtract off the measure of angle 3 from both sides. So this occurs through subtraction. So we need a subtraction property. Oh, it's a alternative form of the addition property. We could just say the addition property of equality there. Since those were both added on, it makes sense we could subtract them off as the addition property of equality. Now, what two triangles are now congruent by SAS? We would have to say that, well, we've kind of identified angles 6 and 5 are congruent. So angle 6 here and angle 5. We already know that the two sides are congruent to one another, WY and WX. And we know that WZ is congruent to itself by the reflexive property. Therefore, we have side, angle, side for WYZ congruent to WXZ. We ultimately need to say that angle 1 and 2 are congruent by CPCTC here. So we need to, that's why we need to get, here's angle, sorry, you can see that, angle 1 and 2. So let's go ahead and say triangle WYZ is congruent to triangle WXZ by SAS. Now we can say that those two triangles are, or two angles, therefore, YWZ, the ones I just marked, also angle 1 and angle 2, are congruent because of corresponding parts of congruent triangles are congruent. CPCTC. And finally, WZ bisects YWX. That's what we're trying to prove, and that would be just stating the definition of angle bisector. Since they're congruent, we know it follows that WZ bisects that larger angle. Definition of angle bisector. And that concludes our proof. Go ahead and take a break and come back with 18 through 20.